So in this video, we want to look at a different type of inequality, what we call a compound inequality. So there's essentially two types of compound inequalities. Okay. So as the name suggests, this is kind of like two inequalities in one, and you combine them into one condition at the end, right? We typically will divide these into categories of or inequalities and inequalities, okay, because of the words we would use to describe them, right? So we'll first focus on the or compound inequalities. So this might be something where we say that maybe x is greater than or equal to -3, or x is less than or equal to -7. Okay. So note here that if we were going to write this out in, say, interval notation, right, it would look like this: -∞ to -7, union -3. Actually, both of these should be included, right? Because we have that equal sign. -3 to infinity. Okay. So there's kind of this gap in the middle here, right? So the only numbers that are excluded are the numbers between -7 and -3. And it wouldn't really make sense to have an or inequality where there's overlap, right? A lot of times when we're solving things, we'll end up with ones at the end that overlap, and then we can combine them into one statement. So something like this would be a typical example, though, of where we would end up with an or inequality. So what I meant by the last thing is if we have something like x is greater than or equal to -3, or x is greater than or equal to -5. Well, in this case, the first statement is kind of contained in the second statement, right? So just looking at both of these by themselves, we're saying that, sorry, we should have included again, right? This should be -3 to infinity for that left statement, and this right statement should be -5 to infinity, right? But this left statement is completely contained inside this right statement, and this is how we write is contained in with sets. So there's really no reason to have both of them, right? We could just say x is greater than or equal to -5, and that's it. That's all we need. It just takes care of both of them. So there will be kind of like a lot of cleaning up of these statements in this way, in that, we might end up with two conditions that overlap here, and then we can kind of clean them up into one more succinct expression. So like in this case, we would just boil it down and just say, so our answer would be -5 to infinity or something like that, right? Because this takes care of both of those inequalities. So maybe we have the problem, say we want to solve that 2x plus 4 is less than 3, or 3x minus 7 is greater than 5, let's say. So I'm just making these up on the spot. They might end up with messy answers. It doesn't matter what they are. We should be able to solve whatever is thrown at us, right? So we basically would just treat this as two separate inequalities and solve both of them separately. And then if we, and then at the end, we'll kind of combine them into one statement using the interval notation. So we'll solve the left one here. So we just use our normal steps. Okay, so this is less than -1, so x is less than -1/2. And then we say or, we'll add 7 to both sides here. So 3x is greater than 12, so x is greater than 4. So x is either less than -1/2 or greater than 4. Okay, so using interval notation, we can write this as negative infinity to negative 1/2 union 4 to infinity. Okay. So as we can see with the OR inequalities, there's not a whole lot more to it than just a normal inequality. We're just combining the statements at the end. And there's no worry about, if we can combine the statements or anything like that, because it's just either this or that, right? So we just kind of tack them together and we're done. So let's look at the and probabilities now, or sorry, and inequalities, I should say, now. So this would be something like if we say, okay, x is greater than or equal to 3 and x is less than or equal to 7. Okay. So with and inequalities, we first of all need to make sure it makes sense. Sometimes we might have mutually exclusive things, right? And it's not possible for x to satisfy both of these things. And here it's fine because x can be between 3 and 7. So if we wrote this as an inequality, we'd write it like this, right? 3 to 7. Sometimes we like to write and inequalities all in one line. So we might write 3 is less than or equal to x is less than or equal to 7. So this is a convenient notation. Obviously, we're just putting it all into one thing. So it looks a lot nicer. It's kind of easier to read maybe, but it's a little bit harder to solve equations this way, right? When you have all these moving pieces. So we often like to break it up into two inequalities if we actually have like an equation to solve in there. But otherwise it's fine to just keep it like this. It's always fine to keep it like this, but it's maybe easier to break it up if you're solving an equation. And we'll see some examples like that. Okay. Now, say if we have something like x is greater than or equal to 3 and x is less than 0. Okay. Now, this doesn't make any sense. Okay, if we just think about what this is saying that x has to be both greater than 3 or equal to 3, and it has to be less than 0. So it needs to satisfy both of these, and there is no number that will satisfy both of these. So in this case, we would just say that there's no solution. Okay. So this is something that could come up pretty commonly in these and inequalities here. I keep wanting to say probabilities because we also use and or probabilities very often. So let's do some examples of some actual equations in these. Maybe we just have something like 3 is less than or equal to 2x plus 2, which is less than 6. Okay. So with a simple inequality like this, we could just do it all at once. Like we don't need to worry about breaking it up into two different inequalities. But we can do it both ways and just kind of see what I mean by both of these things. So the first way, if we just solve it as is, we're just kind of solving it like we're solving two different inequalities at the same time. So when we subtract 2 from the middle, we subtract 2 from everything. Okay. So instead of when we normally say like subtract 2 from both sides, now it's like subtract 2 from every side, right? So we get 1 is less than or equal to 2x, which is less than 6. Okay. And now we divide by 2, divide everything by 2, and we get 1/2 is less than or equal to x is less than 3. Okay. So x has to be between 1/2 and 3, including the 1/2, not including the 3. So we would write that like this. Okay. Now, if we want to break this up into two different inequalities, this is more, like I said, just a kind of a personal preference, how you want to do it. You can break this up into two different ones. So we get 3 is less than or equal to 2x plus 2, and 2x plus 2, maybe I'll do a different color for this one just to kind of color code it here. 2x plus 2 is less than 6. Okay, so we think of it as two separate inequalities and then we bring it together at the end. So just doing this right one first, so we subtract 2 from both sides, we get 2x less than 4. Now I'm thinking I did something wrong up here. I sure did. Okay, so just pointing this out here. I mean, we all make these simple mistakes all the time, so just want to point it out when I do it right here, right? So this should have been a 4, which would make this a 2. Makes that a 2 as well, right? So I just forgot to subtract the 2 from the 6. Okay, otherwise I think it looks okay. So this is one advantage of doing it both ways. You know, kind of doing the problem twice, so you can catch those little mistakes. So now we can divide both sides by 2, and we get x is less than 2. Okay. Now on the left inequality, we'll subtract 2 from both sides. We'll get 1 is less than or equal to 2x. Divide both sides by 2, 1/2 is less than or equal to x. So we get that x is greater than or equal to 1/2 and x is less than 2. So combining these into one statement would read like this, right? So exactly the same thing, either way we do it. So I think it's kind of preferential to break it up into two different statements in a lot of cases, just because it's easier to keep track of everything. You don't have to think of solving two of them at the same time, especially once you get negative numbers in there and you start doing some sign flips, right? Stuff like that. All right, so let's do one more example here. Let's say that we have 3y less than 4 minus 5y is less than 5 plus 3y. Okay, and we'll break this up into two separate inequalities. Okay, so we have 3y is less than 4 minus 5y. And then we have 4 minus 5y is less than 5 plus 3y. Okay, so again, feel free to keep it all on one line. I just kind of like breaking it up here. So since I'm already on the purple, let's go with the purple one, the right one here. So we just want to bring all the variables to one side, so we'll add 5y to both sides. So we get 4 is less than 5 plus 8y. And then we'll subtract 5 from both sides, so we get negative 1 is less than 8y. And then we'll divide both sides by 8. So negative 1/8 is less than y. Okay. Now we add 5y on the other side. So we get 8y is less than 4. And then we get y is less than 4/8, which equals 1/2. Okay. So we can reduce that fraction there. So y is less than 1/2 and greater than negative 1/8. And importantly, that is possible, right? It can satisfy both. You need to make sure that it can satisfy both. So we get our answer as negative 1/8 to 1/2. Okay. If you want to put the variable in here, there's different ways of writing this. Sometimes you might write like y is in this interval, which you write like this. Some people like to use the set notation. So it'll be like all y's such that y is in this right here. So something like this. As long as you have the negative 1/8 to 1/2 though, I think it's pretty clear what the answer should be.